Yeah, I'm good.
Yes. Yeah, good.
Thank you. So I'm talking about DevOps today and how it is progressing, what are the market values, and how we can learn, what are the things, what are the tools we can learn in this. So I hope everyone aware of virtualization and you know something about AWS. Yes or no? AWS Cloud,
Yes.
you have account?
Yeah,
Uh,
I have
I
one.
did enroll for a free one in
Yeah,
the
free
past.
trial version. You have, if
Yeah.
you don't have, just make it create available with the next session onwards. So
Sure.
just another mail ID required to create, I think so.
Yeah.
Yeah. So most of our work, learning process, lab work, which will be on your cloud. So cloud can be any cloud we can use. So first half we will go with the AWS, second half we can go with the Azure cloud, so that we can aware of both clouds and best of industry. We can work with the cross cloud communications anytime, any requirements we can handle. That is what our agenda. So the course covers Git and Jenkins automation, and then we are going for some of the experiments with automation activities where we can deploy some applications using Apache Tomcat, and then Maven. It is going to involve to build the applications, and we can also store the artifacts into jFrog. So these are all different aspects, and we can cover of each one of them, and which are most commonly used in DevOps activities. So other than that, high end, if you look at the containerization microservices that comes with the Docker. So Dockerization, first, the biggest one are the most weightage learning, and then Kubernetes. So Docker maintains the containers. We can create containers and run the containers. Containers we can make high availability, and deployment is made simple using the Kubernetes. Kubernetes is a tool that helps the containers to run on a high availability platforms. More number of containers we can run in that one. Yeah, so going forward, we'll learn the configuration management using the Ansible. This configuration management you can do on Linux, on the Windows, on Unix systems, anything. So we'll learn something on basic Unix platforms. We will work with, sorry, Linux platforms using the CentOS or latest versions of Rocky Linux. So that's about a brief intro, what we are going to do. So I'll just give some details about myself. So my name is Pavan Devapanda, and yeah, I have reachability here on the YouTube and Twitter, and you can also reach me on the Instagram. And these are my learnings and what I'm right now. So right now I'm working as a lead DevSecOps engineer, and cloud technologies. I worked on Oracle Cloud, AWS, and GCP, and Azure also I have worked. So DevOps engineering is a main concept. Since 8 years, I'm working into the same platform, DevOps. So earlier to this one, I was into build and release engineering, and some of the projects right now still they are going to call it as DevOps build release engineer jobs also. So the main core area, the continuous integration, the deployment process, want to automate using the CI/CD process. So CI means continuous integration, and CD means continuous delivery. So build process and coming to the release process, these two things are automating, and the automations can be in different formats. We can use a shell script, we can use the Groovy script, we can use a lot of other options. Each tool is having different abilities. Yep, we can explore that one. Yeah, so you can reach my blogs. So technical blogs, I have DevOps Hunter, and other than that, which are maybe my previous past experiences related to middleware technologies. I worked on WLST, Oracle Fusion Middleware. I worked on most of the shell scripting automations, Jython and Python, etc. All right, and that's about me. Let's begin. What is DevOps? So, who introduced the DevOps? DevOps is introduced around 2009, and it is started by Patrick DeBoss. He's from Belgium, and there was a discussion and there was a conference. In that one, they started coining this particular word, development and operations together. We want to work together. So the main origin is like Linux. So Linus Torvalds initiated open source programming, open source softwares. So Linux actually open source operating system, which you all aware of it. So whatever the latest functionality you want, everyone can see and anyone can contribute new functionality. That's what the advantage of using the open source tools. So whatever we are going to see in the DevOps, the most of the tools are open source tools. So open source is a main core area which we are going to look into. If you go for a Docker, Kubernetes also, it's open source. Learning purpose, everything is available on internet and we can install it and run it. But working with the real-time and enterprise level applications, we must have a license on that projects. Okay, so there are different projects, models in software development. If you get confused or you want to raise any question, you can ask me anytime. So whenever you develop something software, anything, you can take the as an example banking, or you want to go with the insurance projects. They are going to maintain um, sensitive data. Banking data, it's a very sensitive. You want to develop in-house. You don't want to put it somewhere outside. That's the main reason the waterfall methodology still exists and it is going on. So waterfall, what does it do and how the things goes on? It was a long story, but there are phases, different phases. The design phase will be designing about the software. Next, the implementation coding part, development team is going to work on that one. Once that is complete, then every phase is going to have a lot of time consumption, and each phase is going to one phase to another phase. If you are going to switch, it is going to have a longer period, approvals and management interventions, etc. So now that process is changed of from 90s, because lean methodology introduced by Toyota car company. So Japan people introduced and they got successful with that one. The main reason with the using of this lean methodology is just try to remove unnecessary options which are in your system. That is the main key point, so that the everything is become so thinner. That is what giving the advantage for the cloud development. And whatever we are going to learn, work on the DevOps, that is completely based on this important one single line, unnecessary options from the system remove. Okay, so the adoption this into the IT started from 2003, and unnecessary software features. We just take the one simple example. If you are going to take the Linux operating system, Linux is open source system. Everyone can use that one, right? So Linux operating system, anyone can download. But if you take one simple Red Hat, or if you take CentOS, it takes a real software CDs or ISO file around 6 GB size installation configuration part. If we want to run a CentOS server, we can make that a removal of unnecessary features. Then we are going to get the squeezed boxes. Squeezed boxes are used in virtualization. Squeezed boxes don't have all features which are required to run a server. That is what we are going to have. So when you look at the Windows system, you have GUI, but when you look into the Linux system, you don't need the GUI or accessing mouse and etc. That those Extra things are not required. So those things are removed and virtualization got into the picture. Okay, so that's where the development process is thinner and lean, and it is moving good in DevOps. So lean methodology, it's a lot of other technologies, techniques are there in the lean. So when you work with the lean, it's a very big learning process. Lean methodology, how to work. That is a different course at Japan. So what does it do in a high level? You can just see it's a continuous improvement process. And if you have some team members which are who are working since long time, so they will get a good respect in the team, and they are going to take care of what are the existing systems. So if you have a new team members, teamwork is going to be distributed, and the shortest time they are going to deliver. So how you are going to solve the problem is the most important thing is Kaizen. So Kaizen is an improvement process. So the how that could be implemented, how it is breakdown. So when you take some problem, you are going to break into small pieces, and one process, one particular problem, it is going to solve. Okay, and each challenge will be accepted by team member, and they are going to work on it, and respectively they are going to deliver that one. So that is what the lean idea. Okay, so the lean idea implementation is inherited into a new software development methodology, that is, they named it as agile. Agile is a process where we have all the processes what you have in the regular waterfall model. So whenever you want to start some project, it is going to have different phases. So you are going to have plan phase. Plan is going to come into the picture when that implementation is successful. Develop the code and then testing phase is completes. So once the testing is done, then it will go for the huge number of testing gives the success result. Then it will be implemented to production live environment. That is a deployment phase. So deployment is going good, and then we are going to take the reviews of the customer client where we are using that applications. So this is a complete cycle. It is keep going: plan, design, development, in testing, deploying, and reviewing. So this rotation is having a shortest path. Earlier, if you take waterfall model, it is 6 months to 1 year implementation, and it is going to have all number of issues. It is going to fix all bugs will be raised by the different areas, and they are going to resolve. But here, every week there will be a bug. Every week somebody is working on it, and 2 weeks is a maximum time to close the issues. So that is what evaluation. That is what the agile methodology logic. So if you compare with the previous delivery deployments are much more faster. That is what customer is very happy with the DevOps implemented companies. So the DevOps is going to be infinite loop. It is continuously happening. And this infinity symbol, that is what represents the DevOps. The logic here, the 6 things which is continuously happening, and endless. Any software development that is continuously happening. So plan, and whenever you are going to work with the different phases, one phase is on the development side, another phase is on the operations side. Okay, so this part, blue color, what you are seeing, that is non-production. What you are seeing in the yellow color, that is operations side. So whenever the release process is takes place, the two phases will be continuously working hand in hand, and whenever you find some issues, and that will be given back as a new bug, it is zeros will be used in implementation of that particular issues. So that's about what is an infinity loop, why we are using this in our DevOps. Okay, so DevOps just adding new new things with the DevOps, that is security features. What is the difference between DevOps and DevSecOps? So the same thing what you are seeing in the earlier, but it is adding the new flavor of security perspective. The perspective is changed. So every time you have to look for these important things what you are having around the infinity loop. So when you are doing the development, planning something, then there should be policies. You need to define how it should work. That should not lose main importance, and who is going to work on application code changes, etc. So that is the policies. And threat model. Is there any threat is going to happen on your code? So vulnerability checks are very important. So when you're working on the code, that code can be developed in Java or some other languages. So the threat model should check that code. That is the important thing. The next one is static analysis. Code is developed, then you're going to store in one particular SCM, source code management system. So that can be Git or GitHub, GitLab. There are a lot of tools. So when you're storing there, it should be properly analyzed. Is there any problems that hackers can enter into your applications? So that static analysis should be done. Next, code review. So one developer is working. Let's say Mohit is working. Then Dilip or Kiran is going to review that one, whatever he developed. So that is a regular practice. So each one who develops a code, that will be cross-checked by some other team member. That is what regular practice in the DevSecOps. Penetration testing. So this is a most important thing. The code is built, then we are going to test. So during the test, a lot of load and a lot of uh, the testing will be based on the how the intruder is going to enter into the application. That is what it is going to check. There are some separate tools for testing this penetration test. It's cybersecurity team is going to work on that one. The separate reports will be generated. Based on the reports, we need to take the actions and work on that one. Then compliance validation. Every month there is a DevSecOps team is going to have a scan across all the machines. Suppose I'm working with a project, it is going to have some 3,000 machines, VMs, across my project. It might be different data centers. So once that different every month they are going to have a, let's say 15th of so and so month every month. So every 15th it is going to run a scanner across the machines and then finds that is there any patching pending. So system level patchings, operating system level patchings, Linux systems, Windows systems, they are going to have the different patching requirements. Every month they are going to release the patch, and it is not implemented, not installed on your one of the system, then that can be possibility of intruder entries. So we should not give any chance. So that's why the production systems need to be always compliance free. Okay, so that is what the important thing. Monitoring process, the regular process where we are going to use different monitoring tools. And whenever system is in live, continuous monitoring is important thing. So continuous monitoring is supported by Prometheus, Grafana, and Kibana. Different tools are there, but don't worry about all those at the moment. We can just have a names and understand there is a tool that will monitor. So what kind of monitoring? We have two types of monitorings. One is application level, uh, how the performance is. So APM, application performance monitoring. Another one is system. So system level, you're going to have CPU loads, memory, disk space. These are the common requirements need to monitor. So why we need to monitor? If something goes overloaded, something memory is overloaded, in that cases, what you can do, you can simply find that on the dashboards and immediately work on that particular host our data centers and resolve the issues. That is what the help where alerts also very important when we are going to monitor. So monitoring system is always configure certain alerting mechanism. Alerts will go to your Slack channels or messaging systems, or you can also have an email. So that is a last option. So immediate action, who is on call, who is going to work on that particular day session, they are going to take the action and resolve the issue immediately by monitoring. That is what the DevSecOps abilities. So threat intelligence, threats monitoring, threats finding, that is a separate security team is going to work. And auditing, regular auditing is very important. So every month, how many users? Because every company they're going to hire and fire. If the new member join, is he having enough credentials to access the system? If a person who left the company, they are still having the user, then how that is going to be closed? So those things are tracked, audited. So every month, the list of users who are left, they are going to be removed from the system. That is what the requirement. Logs and threat models, these are the very important. So logs always focus on the application. So application level, it is going to generate the logs, and we can look into the logs to identify where is the issue, how the problem arises during the application performance slowness. Hello, are you with me? Able to hear me? I got some message like internet is slow.
Yeah, I'm good.
Yeah, we can hear you.
Thank you. So the new requirements in the current projects, that is SRE. So SRE word is coined by Google. So Google is find how the SRE is going to work. Google platforms, Google clouds, they are using the different level of infrastructures. So the same structures will work with the AWS, same with the any cloud. So first important thing is how that your system is working at the storage level. So storage, how much secure it is, what kind of storage we are using, those things will be taken care by SR. And application products which we are going to use, there are different application products we are going to use, software products. So the product licenses, product is going to be securely accessible. So when you are working on that one, you need to look for the Shrikant, I'm getting noise.
My apologies. Sorry, Paul.
You can mute if you don't have anything. Thank you. Yep. So we have the products. The product can be software product, any product which you are going to have that should be protected. So you should have a continuous testing where we are going to have the infrastructure automations. So automations helps make very easy to handle the issues. Huge number of environments we can easily handle. That is what we are going to learn in our DevOps tools. So Ansible and Terraform, these are the two things which are most commonly called as a infrastructure as code. So automations inside the infrastructure development, where we are going to need like one machine which we can configure using the mouse and click next. But if you want to make 50 or 100 same kind of VMs, for example, then you need to go with the scripting automations. And one system we developed, at any point of time, if something crashes, again, you need to get it back. So if it is written in somewhere, you can get it back. That is what the advantage we will get from the infrastructure as a code using Ansible or using Terraform. Okay, so there are different traffic platforms, the routing, the network routings, etc. So those things also comes into the site reliability engineering. So you should aware of proxies settings, and you should aware of how the load balancing is happening to your application. So these are the basic things which our site reliability engineer is going to work on. So all the three roles, DevOps engineer, DevSecOps engineer, SRE, most tools what they are using are same what we are going to learn in our course. Git, Jenkins, Docker, Kubernetes, and infrastructure as a code with the Ansible or Terraform. So these are the things. That's why I just want to highlight what kind of things are relates with each role. Yeah. So why DevOps is important? So these are the important advantages why I'm learning, why we are going to use in the company. The companies are going to fastest time because immediately they are going to deliver that requirement. Amazon is deploying their application, that e-commerce application, every minute, one time the new deployment happens in a that is the frequency of changes they are going to get. The frequency is important, and how frequently you are going to give the best new updates. The customer is more happy. So customer is happy, then you will get more money. Business is successful. So that's why faster time to market, lower cost to delivery because it's just 2 weeks sprints we are going to have. Agile methodology talks about 2 weeks changes. So DevOps always follow the timelines and deliver things. So we need to understand how that could work in DevOps. And no vendor lock-in. So always whenever we work on DevOps, first POCs, whenever we do, it is always open source products. Docker, Kubernetes, everything is open source, and we learn about how to use them. Higher quality and few bugs. Whenever we work on a DevOps, it is going to give more quality of the product or software what customers are using, and few bugs because every bug we are going to close very soon. So within 2 weeks it will be disappear. So that's why very few bugs will remain for longer time. Multi-cloud architectures are supported by DevOps. So if you go for AWS, they are implementing AWS DevOps, Azure DevOps. So like that, every cloud they are supporting DevOps, and cross-platform. If you want to use, then common tools we have to use. So that's why Git, Jenkins, and Docker Kubernetes we are going to see in detail. All right. In between, any questions? All good? Are you following me?
Yeah.
Yeah, so far good.
Thank you. So DevOps is like a culture which we are going to develop. We need to cooperate with the development team and operations team together and work on it. So that's a culture. So how that DevOps works, this is the step-by-step process. First plan, code, and then build it, and then test it. Release that. That is the artifact which you are going to have. Jar files, var files, or images which goes to the containers. Once that is done, this part is production part, deployment, that will go to the live and operate. So keep operating. It is going to scale up, scale down. Number of instances going to get this deployment. And you can also see continuous monitoring is important aspect. So these are the activities which we are going to do in our DevOps. Most of our learning will be around this DevOps culture. Okay, so how DevOps is going to work? The most common steps, any project, these are the steps. So DevOps is going to broadly achieve the below 5 phases. First phase is collaborative development. Anything you are going to work on the DevOps platform, there is always code development. So code development can be two types. You don't need to write Java program, but the code will be related to infrastructure. So infrastructure, what we're going to do, you may be working on the EC2 instance in AWS or virtualization VMs. So that is the first step where how the code is working. That is the code. And once you are done with the VM creation, who is going to work, development team, then how we are going to collaborate, how many VMs you want, how much testing is required. So all these things we are going to consider and work with them and try to prepare one by one phase. So development phase, after that continuous testing, continuous integration. So once that artifacts are generated, where you are going to store, you might use the jFrog, you might use something else to store the outputs. So that is the integration part. Continuous delivery or deployment. This is, we are going to have a different environments, testing, development, and production environments in real-time software developments. Continuous monitoring. This is into the operation side when it will go to the live, and it is going to be in the fifth phase. Okay, so Git, when you're working on the Git, the source code, that is what we are going to learn. So I'm just giving one by one what are the tools we are going to explore. So Git is a tool which we are going to learn first, and we will work on the some of the commands and how it is working, where it is applicable, Git, GitLab, or GitHub, Bitbucket. So there are different new technologies coming into the Git. So these are all different server technologies that will help us to store the source code. Okay, so any one of them we can use. So most commonly, easily public accessible, that is GitHub. So we'll try with the GitHub, and if time permits, we can see Bitbucket if possible. Yeah, so that depends on the cost effects and how we are going to work on a team. That is also matters. Some of the projects, they will go with this GitLab or Bitbucket. So in that case, the commands what we're going to learn, that is common in all of them. So what I'm going to teach you, the same thing will work in the GitLab, same thing will work in the Bitbucket also. So we'll deal with this public cloud. The second topic tool which we're going to learn in DevOps is continuous integration. So any project, this is a common requirement, and Java based server. Jenkins is a Java based server. You can run a Jenkins master slave architecture, master slave implementation, where we can run the pipelines. Pipelines help us to continuously integrate, continuously deliver the applications. Okay, anything you can automate, and we can have some basic idea about scripting. The shell script common mostly we are going to use, and Maven configurations, that is also automate. Some of the jFrog related configurations we will learn in the Jenkins topic. Yeah, so the third tool which we're going to learn is Docker. Docker is helping us to create containers. Containerization is a technology which is most widely used in the most of the cloud. So AWS or Azure, GCP, anywhere we can see the containerization, the smallest size of OS operating systems, and we can have the applications in any language. So you can have a container, in that one you can have a Java application. Another container can have a Python application. Another will run on a MySQL database container. So anything is possible to communicate easily. Container by container we can create, and Docker is a tool which will help to create the containers. We'll learn that one and move on the high availability on the containers. So orchestration of the containers is Kubernetes is a tool where we are going to have the
I'm sorry. Can you please explain me about the Jenkins part? The meeting was disconnected.
Yep.
You're explaining that, and I missed that part actually. I'm sorry.
No issues.
Thank you.
Yeah, Jenkins continuous integration tool, CI. Initially, it was developed for any Java applications. So we can use now the Jenkins for not only Java. You can also work on .NET applications. We can work on Python applications as well. So applications will be continuously integrated, and we are going to make a combined output that we are going to call it as a build. So build is going to create some jar files, var files in case of Java. And if it is some Dockerization in automations, then image will be the output. So that will be stored at one particular common place where we are going to use a jFrog as a learning object in our course. So where we can store the artifacts. Whenever you want to deliver it, it will be sent to server. So the server can be something like Tomcat for Java application, where we deploy the application. So that is how the CI and CD will be learned in our course. So the entire process we can do with the normal Jenkins jobs, and we can also use the pipelines. So we'll go with the pipelines, which is the latest requirements in most of the projects. We'll try to create some couple of pipelines, understand how that automation will goes on, right?
Yeah,
Um,
thank you so much.
yep. So hope you heard about containerization. Docker is a tool which we are going to learn. And yeah, so that is the top one, which we are going to use in a high availability architecture. So whenever you want to make the cluster is same server, you're going to have multiple servers together serving the same application. So cluster can be of containers, and each container will be sit into one room. That is, we're going to call it as a pod. So pods, number of pods, let's say web application we want to run, each web application or database application or load balancing. So each one is having a different abilities that will be called as a group, and that group will be forming as a service. So that services we are going to integrate, orchestrate in the Kubernetes. So each one is having some deployment process, and we'll see how we can store the data if there is a need of storage, like database applications need huge number of volumes. So volumes helps to store the data. And integration and networking is the most common thing. So Kubernetes networking helps to communicate some services. Let's say a web application want to talk to the load balancer, or coming back to the back end, the web application want to talk to the database services, data services. So like that, we can have a communication, and the front end is always required open to everyone, and back end always secured one. It will be only accessible by the application. So how we can make that one? That is what the networking in the Kubernetes. And accessing one particular application, you can have two different ways. One is user application access. Another one is application to application, software to software authenticating. So here we are going to have a master slave architecture, and master is always giving the token and slave is taking the token and communicating. So it is always security communication. So security will be always used with the authentication, and that is what implemented successfully in the Kubernetes. Kubernetes is most widely used in the market, in almost all every cloud they are using, and they are having a lot of tools also coming up for the Kubernetes to make life easier. Okay, first we will try to understand how the Kubernetes, how the architecture works, how we can make master slave communication, how the application deployment will work, how the services will work. So all these things we will try to understand in detail. Yeah. The next one is the Ansible configuration management tool. So this is a tool, and whenever we want to work on something, the coding is required in the Ansible. So it's a scripting, like we are going to develop the script with the YAML, YAML. That's a structure. And writing YAMLs is called playbooks. So playbook will be play in Ansible controller, and you are going to execute something, an automated thing. It is going to handle files. You can configure some files. You can start the services, web applications you want to start, or MySQL database you want to stop and start. Anything we can do with the Ansible. So there are some particular templates. Let's say I'm working on a web application. So the web application will be in a one particular data center, how it is going to work. You know that one, and you just need to substitute the parameters in the template. So templatization is going to make simpler, same work, repeated task. Only thing you need to pass the parameters and that will be substituted. Okay, so there are different variables which we can use in the Ansible. There are different levels of variables. So that can be host level, that can be group level, that can be execution time. So we'll try to understand how it is going to work. We'll become master in the Ansible. Okay, so this is all the 5 important rules, and maybe if time permits, we are going to work, or definitely we'll have a touch up with the another infrastructure as a code, that is Terraform. So in Terraform, that is we are going to work with the AWS. So in AWS Cloud Terraform, we can maintain the state of the server services. So you can have different services in the AWS. Any one of them you want to launch, you can create. You can create storage like using the S3. You want to run the EC2 instance. So all these things are different services which we can learn, work with the states, different states of Terraform. Each cloud is having different state. So we are going to learn with the AWS. HCL, so HashiCorp is providing this Terraform. HashiCorp related language is HCL. HashiCorp language we learn and try to develop some codes which are mostly available on the internet, and we just need to modify and change and run it. So we'll work on that one with the AWS and provision some of the services, and we also create some modules in Terraform. I will deal with the different modules. I will work with the functions. We'll work with the conditional situation. Once some event base you want to do, then that is also we'll try to work on the Terraform. So these are the tools we are going to learn in the DevOps. Yep. So what is not DevOps? Sometimes you might have question like everything is DevOps. You're saying, then what is DevOps? So DevOps, it's not something, a tool. It is not a software. DevOps is a methodology. DevOps, it's not a fully union of development and operation, but yeah, it's like about to happen, and most of the companies, they are making one particular team, sharing each other, development team what they are developing, operations team what they are monitoring, what are the issues they are having. So that is what they want to exchange, but 100% it is not, but yeah, about to happen. So DevOps exists only on cloud? No, it is exists on premises also. So projects which are running with the different data centers, like the banking project, they don't want to put into cloud, or some other e-commerce project, they don't want to come to the AWS because they fear of Amazon is going to get their logic and they are going to have that. So some of the projects still on the on-premises, some of the projects on the cloud. So on both, DevOps will work. Excuse me. DevOps is not any product, software product, not a single product. You have to see a couple of things. In our course, we are going to see 5 important things we are going to learn. DevOps is not myth, and DevOps is whatever we are going to see. That is what the practice culture. So it doesn't means that developers are responsible for something. Who is going to develop this one, that is what it is going to execute on the production. So it's not like that. Anything is managed by anyone in the team. So DevOps is not means that it is just governance or auditing or security. No, it is going to help us to work on the task. So every month you want to check how many Linux systems having the uptime, 35 days, 30 days limitation. You are going to put the threshold and we are going to run a Ansible script playbook and it is going to get the report. So that is how the logic works governing of our projects. So it is having a lot of wide scope to learn and develop in the real-time projects. So out of our course, what you are going to take away? Take away is like this. You are going to learn about Git. Jenkins with the CI/CD, configuration management, that is Ansible. We also touch up with the Tomcat server, application server, AWS cloud, Vagrant virtualization. We are going to see monitoring tools. Some of the experiments we are going to do with the Docker containers and Kubernetes. In that case, we are going to use the monitoring tools. Then we are going to learn familiar with the build process and deployment process, Java applications, microservices, how we are going to develop, how it is going to work in real-time projects. We understand how that software industry is looking for. Deployment of high availability using the Kubernetes. So these are the things we are going to do, simulate the things in our lab exercises. Okay. So overall, if it is going to be support agile or scrum strategies, what we are going to have in the current development projects. So this is all a takeaway from DevOps course. Okay, so the scope, job scope, how the jobs are in the current market. There are different software development teams working on. So the de facto standards what we are having, the software development life cycle, you should aware of that flow you're going to get it. And again, the knowledge, how we are going to focus, that is mostly on the infrastructure side. So infrastructure development, we can develop using the DevOps. In our course, we are going to touch up both small experiments with the development, and we'll see how the infrastructure is going to work. So higher and earning resource, which we can see here in European market is like this, 27 GBP, and average per year is like this. And looking at the US market, highest pay is like this, so 114 or 15 something, that is average, and $55 per hour, that is the market value in the US DevOps engineer salary. In India, it's like depends on the company to company, strategy is changing. Okay, so that is about job market. Coming to our course content, I have shared already this content you have already. So we'll go with the step-by-step process. And anything, any questions?
No problem.
Okay. So I have some questions to you guys. And you belongs to IT and the student. Are you able to work with the laptops immediately when I tell you create one VM? Are you comfortable, Kiran?
Yeah,
Yes.
Yeah.
yeah,
Yeah. So you have your own laptops and you are connecting from laptops, right?
yep.
Yes.
Personal laptops. Okay.
Mhm.
Um, I wish you could start downloading the two important softwares for next session. So one is Oracle VirtualBox and the second one is Vagrant. Okay, so that is, if you make it ready, then next session will start with the lab setup, creation on your laptop, understand the virtualization, how it works.
You said
Uh,
Oracle VirtualBox and then Vagrant, right?
yep, just install them. So we'll try to start creating the one small virtual machine configuration in next session. So that is what agenda. Okay, so hope you understood everything is fine, clear what we are going to learn in our course, right? Are you with
Yes,
me?
Pawan.
Yeah. So
I
if
have a
you are,
question.
yeah,
I'm sorry. So, is there any particular version number that you're looking at for the VirtualBox or for the Vagrant?
you go with the Windows version of that one, VirtualBox, and take the latest version. So that will works. 7, maybe version 7, VirtualBox,
I'm actually on MacBook.
MacBook. Okay. Then you have to select Mac and see what is the latest version available.
Okay, understood. Yeah, it still says 7.0.
7.1. Okay.
Yeah. Already, I'll download it by tomorrow.
Okay, thank you guys. If you don't have any question, I will stop here.
No, I have no questions. Thank you.
Just a question, Pawan. At beginning, do we go with AWS or Azure?
First, we'll try to create VirtualBox, understand how virtualization works. Then we'll go with the AWS.
Okay.
Yeah, that's why I'm asking Oracle, VirtualBox, and Vagrant.
Okay.
Got it?
Yeah.
Yeah, Dilip, any questions? Dilip, are you with me?
Yes. No, no.
No questions. Okay. Thank you, guys.